Okay, so I'm Dominic Tarr, and this is a modular database. So modular software has been an ancient dream. Like since the early days, people have thought obviously the best way to write programs is to write lots of small programs and have them work together. But this has usually been ruined by the needs of expediency, of like trying to solve the problem we have today has ended up making this dream not work. So for example, Fortran 2 in 1958 had subroutine, which allowed you to put part of the program into a different section of your code. But Fortran 2 had no stack, so you couldn't call a subroutine from a subroutine. So there was only one level of abstraction. This was eventually fixed in Fortran 90. Windows, aka MS-DOS Executive, that depended on dynamically linked libraries, which brought in all the stuff that did the user interface and this sort of stuff. A big deal in 1985, but each DLL was identified by its name. So, and there was one registry for the entire operating system. So, if you installed a new program that needed a different version of a named DLL from another one, then you could install a new program that broke another program, also known as dependency hell. This was eventually fixed in Windows MS-DOS Executive Vista in 2006. Then eventually Node.js came along and we fixed it. Node.js doesn't have dependency hell. We have nested node modules directories, and each module gets its own dependencies. You can even have multiple versions of the same module within the same program, and it won't break. It'll work. It'll probably just work fine. And if you say that this is a good thing to some other people who aren't used to Node, they'll think you're crazy and be like, you have too many dependencies. But this is why that's a problem. This means it's not a problem anymore. It encourages, so if too many modules can break you, then it incentivizes you to write large modules that have less dependencies, because everything they pull in, it increases the chance that further down the track something will break, something unexpected. It's just a time bomb. This means if something already solves that problem, then just use it. And it doesn't matter how many of them you load. So it encourages you to write small modules that are focused on exactly exactly one problem, and just have many dependencies. And so, yeah, this is working really well. The thing with modules, though, is I don't think it's ever really been formally defined. There's no mathematics of modules, and there's some things that passes for the modularity. That's really just organizing files, but it's not just about having separate files. It's about solving one part of a problem, a bigger problem, one part at a time. So a couple of features that I think are essential. So you need nesting. Problems always have subproblems. And then there has to be some way that the modules communicate with each other. So in Node.js, you export a function, and then dependent modules call your function. In Unix, you have Unix utilities that you can pipe into each other, and they can call each other passing command line arguments. And but the most important thing is that the internal details of any particular module needs to be hidden from outside modules, and it can't interfere with what another module does. So your dependencies can't. The dependencies of one module should not interfere with the dependencies of anything else. So that you can add as many modules as you like, and it won't cause problems like so what if we had a modular database? This is kind of like a quick diagram of the sorts of things that a database needs to do. You need to put data in, you need to be able to get data out. To do that, you need indexes, which are like a physical part of the database that helps you find other data. You probably need to separate your data into various types of data. Sometimes you need to replicate data, copy it from one machine to another. That's where things are getting really complicated and interesting. And all of those sort of need basically to separate parts of the database from each other. And often those, like an index, and often queries are just like another view on the data. So you put data in and it generates automatically another way of looking at that data that's useful for a different task, such as retrieving particular data that has particular properties, or retrieving data that's happened since a certain time so you can copy it to another machine. So after much experimenting with flat systems that broke, I eventually figured out this module called level-sublevel. Now what it does is it gives you, you pass it a level-DB instance and the name of a level-DB instance, and that gives you a new object that has this enhanced functionality that adds a sublevel function. And the sublevel function takes one argument, which is a string, which is the name of your subdatabase. Now, then it returns a new database that has exactly the same API as LevelUp, except it's a database within, nested within the larger level-DB. And you can create as many, sub-databases within a database. And sub-databases can also have sub-databases. So you can have create as many databases as you like. There's just two small additions. There's post hooks, which you pass it a function, and whenever a record is inserted, it'll call that function with whatever was inserted or deleted. So you can react to that in some way. And there's pre-hooks, so pre-hook is called, you pass it a function, and it's called before data goes into the database. So if you do a put or a batch, the pre-hook for that database will be triggered, and you can react to, you can inspect the thing, you can veto that thing, you could throw, and then you'll get the callback will get an error instead of putting it into the database. And the second argument is this add function. And if you can pass the add function another option, another value, and then that will also be inserted into the database. And the really important thing here is that anything that you add will be inserted atomically with the data that's going in already. So either the entire insert will succeed or the entire insert will fail, but you know that if you're making a view, if you're making an index or something like that, then the raw user data and the view of it will both be consistent. So immediately after it's succeeded, you'll be able to go and get it out via the index. So in this code example, we're just going to create a log. So whenever something is inserted, we'll have this other log DB that just remembers the time that thing was inserted and the key that it was inserted to. So we'll be able to look at the log DB and retrieve out things since a given time. And here's what the query would look like to get everything that's happened in the last 30 seconds. We'll just create a value stream on the log DB, and we'll pass the start value, which is the date now minus 30,000 milliseconds. And then we'll just output that on console.log, and we'll see the keys that were inserted in that time period. And here's how we might create an index. So say we want to be able to look up data objects by the author's name. So we could add a pre-hook to the database, and then we get the author property, and we add it back as an index. So we had some other primary key which was not related to the author's name, and we'll make it, we'll save it again, but we'll have the author's name and then the original key, and in this case we'll just leave the value to be empty because we don't actually need that because we've all got the information we need inside the key. And we want to make sure that if there are multiple data objects by the same author, then we want them to be next to each other in the database so we can quickly retrieve all of the objects that are by a certain author, but we don't want them to overwrite each other. So if we append the original key afterwards, then we'll be able to, then we'll know who the author, we'll basically group the keys into one section that have the author first. And we'll use an exclamation mark to separate those two fields. The exclamation mark is a good choice here because it's the earliest sorting printable character. So it will give it good sorting properties if you have a late one, or if you have one like a colon or something. Like a colon is sorts in between numbers and letters. So if you have a number at the end of the author's name, you can run into unexpected problems regarding the sorting. Of course, it's worth noting that author's name is not allowed to have an exclamation mark in it. You'd need to check for that sort of stuff. Okay, so this is how you would read it out. You would just create a key stream. You get the author and the end author, and the author is the start and the end. And we'll use the tilde in a similar way because the tilde is the last printable character, that last ASCII printable character, and that will go. So that will get us the start. All of the authors, all of the records created by that author, and then but that will just give us the keys, and then we pipe it through mapstream, and every key that comes off, we'll just get it out of the original database and pass it to the callback, which emits it on the next data, and we'll be able to retrieve all of the data for that author. And then we can easily bundle it into a module that we can just apply to any database that does this name stream thing. So we'll create a sublevel. We'll pass in the name because we may want to apply this multiple times, or we want to pick a different name so it doesn't collide with another sublevel we've added. We just have the prehook, then we add a query function. Missing here is needs to return the subDB, so you can work with the thing because it hasn't actually altered the original database object. And then we can just use that module again. And now we can publish on npm and use, and now we have name indexing. And that's a very simple example, but you can do all kinds of much more complicated things that wouldn't fit on a slide, and would be very useful and focused on a particular type of indexing. So post hooks and pre-hooks are quite different, and it's important to understand when to use one and when to use the other. It's not as simple as just like Unix piping, but a little bit similar because data flows out through one and into the other. But basically, a prehook is atomic. So stuff that's inserted with a prehook will both go in, or neither go in. And post hooks, you get a post hook when something has succeeded. So, but if you try to insert another thing on the post hook, the database could crash. In between then it's saved, and if you're depending on that succeeding as well, then there's a gap where your data, your view may be inconsistent because when you restart, you'll have forgotten that that you needed to create that view, but you hadn't got around to it yet. But post hooks are very good for say communicating with a client. So whenever something has inserted, you can send that message to a client, assuming that if the server crashes, the client will just start over from scratch, essentially, or something like that. So here's using a post hook to keep account of the logged in users. So there's two parts here. So this is sort of a batch mode thing. So when the process starts, we'll just iterate over the entire database and count all of the users that are currently logged in, just by having a variable and incrementing whenever we see one that's logged in. Now, readstream will only return things that are currently in the database at the point that you call create readstream. And then db.post will only call things that have been added to the database after create readstream. So if you do this, you'll get, from this instant when this code executes, everything that's currently in the database will be passed to the onData event of the create readstream, and everything that hasn't been inserted yet, but is inserted in the future, will be passed to the post. So we'll just count each one that's currently logged in, and then when someone additionally logs in or logs out, we'll just increment or decrement the counter. Now that's a greatly simplified thing, and it's technically possible that this could become out of sync, but it probably doesn't matter exactly how many users are logged in or not. And what you can just do is just clear the thing and restart the count like every hour or something like that, and the chance that you've drifted very much. Also, it could drift if you overwrite something twice with two logged in things, where it's like logged in and you write it again, logged in, and then it will be off by one. But it probably only needs to be approximate, so we'll just we can just run this part like every 20 minutes or something like that, and it'll be fine. And we can combine these two parts in interesting ways. So let's say, when we insert data, we have some other thing, like we want to do an aggregation where we read a piece, when a piece of data is inserted, we have to collect a bunch of data, which involves I/O and has to be asynchronous, and then combine that together in some way, and then save that. So we can't do that with the pre-hook because it involves I/O. So it's like a job that we have to trigger. So how we can do this is, when data is inserted, we add a note to ourselves that we have to do this job, and then when the job successfully saves, then we're like, yes, we're doing this now, we're committed to this job. So then we do the job. When the job is finished, when they've called the callback, delete the job from the database. And then, if the process crashes sometime in this phase, then when we come back up, we can just scan the database for any jobs that we're committed to but haven't completed yet, and then we just start them again. Now, this would guarantee that that every job is done at least once. So it's entirely possible that we end up doing the same job twice. So the jobs need to be designed in a way that if it does run twice, it won't have double the effect, it will just have the same result. Yep. Yep, so that's sort of basically how, I want to show you this though. So if you track back, if you look at how the history of the universe, so dynamic languages, GIFs, the internet starts to happen. I got Internet Access 94, JavaScript, Internet Explorer, and like a whole bunch of shit happens, and most of this is all in the past now. Node.js began in 2009. Before, most of this other stuff that we consider to be the modern age of the internet has already happened. Now look at this, Node.js, like the other things, like CPAN was 95, was like nearly 10 years after Perl was created, but Node started to happen, and NPM could install things later that year. The gap between Node.js and it having a package manager was very, very short. And this, the module system was actually refactored after the package manager was created to make it work better. That's how we ended up with such a good module system. And so modularity isn't a solved problem. It's like it's a process that we're still working on. So 2013, what's next? I have a theory. So currently, this is how the web works. You have the cloud, which is a hypervisor with a whole bunch of VMs inside, and a web browser, essentially exactly the same thing, but every tab is inside its own process. It's separated from other tabs, just like a VM. The only thing is you don't have root access, and there's all kinds of weird crippled, and it's crippled in weird ways, like same origin policy and that sort of stuff. But what if we had a modular operating system where you could have nested VMs? I think this thing here, native client, is going to be very interesting. It was a potential web standard that didn't catch on, but on the server side, I think this has potential, and there's a project called ZeroVM. Which can actually do nested VMs. So your process becomes an operating system and can have arbitrary, untrusted code running inside it. I think that may be the next phase. Thank you.